Okay, I'm not going to do all the problems in this on this document, but just going to do a little summation here. Critical points are, there's the skip, the vertex, the y-intercept, and the solutions, also known as the x-intercepts, or the zeros. Okay. Let's see here. Here is a parabola. There's the y-intercept. There are the solutions. And here is the vertex. Again, the axis of symmetry would be a vertical line that goes down through that vertex. Okay, now in equations, usually you see equations written in this form: y equals ax squared plus bx plus c. This a value, this number in front of the x squared, that tells us a fair amount about parabola. Okay, if the a is positive, the parabola opens upward like a U. Okay, if a is negative, parabola opens downward. Okay, now there's some more we're going to do with that. As a gets farther from 0, the parabola gets steeper. As a gets closer to 0, the parabola gets wider. So what do I mean by that? Again, this is kind of a regular parabola that you see all the time. This might have an a value of 1. And then let's say you have an a value that's even closer to 0, like 1/2 or 1/3. Then your parabola gets wider, you see? Okay. And then if you have an a value of, let's say, 10, then the parabola gets super steep. Could be something like this. Okay. So the closer it is to 0, the wider it gets. The further away from 0, the steeper it gets. Okay, now I'm going to talk through a couple of these, and then the rest, I'm not going to do this whole sheet. I'll post these solutions at some point, though. So here, what you can do is, right away, this a value you see is negative, so that means it opens down. The y-intercept always has an x value of 0. If I plug in 0, that goes away, that goes away. The y-intercept, when it's in standard form, is always that number hanging off the back. So I know that that's my y-intercept. I know that this parabola is going to open down. Okay, here's something new. So you got to pay attention here. The vertex. The x value of the vertex. Actually, let's say the x coordinate is always equal to the opposite of b over 2a. That's a big deal, something new. So let's jot down our a, b, and c for this problem. And they're all negative. A is -1, b is -6, c is not c, c is -5. So if I'm going to do the x value, the opposite of b would be positive 6 over 2 times a. That would be 6 over negative 2, which is negative 3. But remember, that is just the x value of the vertex. The vertex is two numbers, is an x and a y. Okay? So how to find the y, it's not hard to do, but it's easy to mess up. So what you're going to do is you're going to take that x value, that negative 3. We're going to plug it in for x here, and then evaluate to figure out what y is, if my computer will cooperate and come back. All right, so watch this here. Y equals, that negative sign's still there. Now I'm going to replace this x with negative 3. And that's what you got to be careful with, because most students see these two negatives and they make it a positive. That's not right. That violates PEMDAS. You see, negative 3 squared would be positive 9, and then 9 times negative 1 would be negative 9. Negative times a negative is positive. So negative 9 plus 18 is 9 minus 5. You get a y value of 4. Remember, that's the y value of your vertex. 1, 2, 3, 1, 2, 3, 4. So we know this opens downwards, and we know that's the y-intercept. But I still need more information here. We only have 2 of the critical points. Whoops. Didn't mean to go that far. So my axis of symmetry would be that. Okay. And remember, that goes through the x value of the vertex. So the equation of that is x equals, I know this would be x equals negative 3. These two numbers always match. If they don't, you messed up. Okay. Now the zeros, remember the zeros, it's called zeros because the y is 0. So I'm going to take the original equation and I'm going to rewrite it. But I don't like this leading coefficient being negative, so I'm going to multiply both sides by negative 1. I can do that. Negative 1 times 0 is still 0, you see? But these signs all change. This is an easy thing to factor. There's no GCF. And we get x equals negative 5, x equals negative 1. So I'm going to go up to my graph, negative 5 and negative 1, and now I have my 4 critical points. But you know one thing I don't like? You see how these points are each 2 units away from the axis of symmetry? This point needs a mate. You see how this is 1, 2, 3 units away? 1, 2, 3 units away. There's its mirror image right there. So our parabola would look like that. There, we just did one. Okay? That's not that bad. I'm going to talk through one more in this video. And then again, you can pause, stop, whatever you got to do, as many times as you need to. And then the rest of this will just be, you can practice on your own. So here, A is positive, so that opens up. Y-intercept is this number, 0, 12. Vertex, x equals opposite of B, all over 2 times A. So that'd be negative 8 over 2, which is negative 4. But remember, that is just the x value, so I got to plug negative 4 in here. Negative 4 squared is 16. Negative 4 times 8 is negative 32. So if I do 16 minus 32 plus 12, I will get negative 4 coincidentally again. So my vertex is negative 4, negative 4. My y-intercept is 0, 12. Axis of symmetry, remember, is x equals that number. So 1, 2, 3, 4, 1, 2, 3, 4. There's the vertex. And we said the y-intercept was, I think it was 0, 12, right? So that would be, this is 9, 10, 11, 12, be about right there. Okay. So we need to find the zeros, right? And there's a spot to do that right here. Change the equation. Remember, f of x is the same thing as y. We change that to 0. And we can factor this as well. Remember, if it doesn't factor, you might have to use quadratic formula. This is going to be 6 and 2. X equals -2, x equals -6. So I'm going to go to my graph here. -6, 1, 2, 3, 4, 5, 6. -2. Okay. And, we about have it. Here's my axis of symmetry. And, this point has a mate, 1, 2, 3, 4. 1, 2, 3, 4 is going to be about right there. Doesn't have to be perfect when you're off the graph like that, but. And you should draw a nice curve. There we go.